So when I created my student class, I made a way to construct students. But when I tried to print those students out, I got this like nasty looking junk at the bottom of the screen. It's certainly not what I wanted. I probably wanted their name and their age. So I'm going to go back and click on the student tab to take me back to my student class. This is why toString is a really special method. You'll notice that if I want to call on other methods, so for example, if I wanted, let's see, my student X currently doesn't have a name, I could say x.setName. Notice how that comes up because that's a method that I created in the student class. And then I could give it a name like there. Now X has a name. But even so, when I run it, I still get this junk at the bottom. That's not what I wanted. So normally when I call on a method, I call on it by using the name of the object, which in this case is X, and then dot, that's a method selector, and then the name of the method, which is setName, and then any parameters if there are any, and in this case, there's a string parameter. The thing that's special about toString is that I don't have to directly call on the toString method. Java is smart enough to figure out that if I'm trying to use an object as a string, it looks for a toString method. So that's public, and it is going to return a string, and it's called toString. And it has to be called toString in exactly that spelling. And it is going to return however I want this student to look. So any student object, what do I want it to look like as a string? So I might want to say something like name, and then give the name of that particular instance. And then I might want a new line and say age, and then give the age of that particular instance. And there is my toString. So now I'm going to just run that to save it. But now notice when I run my student tester, voila, I get name, age, name, age, name, age. I probably should put in little \ns in here so that when I run it, notice how Michael's age is 0. That's because I haven't set up an age for Michael. I only set a name. Max's age is 0. Same reason. Max has a name but no age. But Annie got a name and an age, and that's because when I constructed my Annie object, Z, I gave it both pieces of information. The final thing that I want to talk about is static. When I create a static instance variable, so I'll call it teacher. This means that I'll set it equal to Ms. Hunt. So this means that if I change teacher for one object, like let's say that I have a change teacher method. So that's going to be void, and I'm going to call it set teacher. Oh, and I'll let them set it to some other name. And then teacher is going to become whatever they say. The difference is now when it'll run just fine. I haven't called on set teacher yet. But right now, if I try to print out, I have to get a way to do this. I'll say teacher, and I'll just print that. This is any object's teacher. So now comes out, Miss Hunt, is every single object has the same teacher. That's static. Now, if I change it for one, it's going to change for everybody, which is, kind of important. But what's very interesting is that instead of using one of these objects to call on that, let's make this a static method. If this is a static method, that means that I don't have to use an object to call on it. I can just use the class name. So I can just say student dot set teacher. And I can set it to somebody else. Let's set it to Miss there. Now, everybody's teacher got changed. I didn't call on it with any particular object. I just could call on it using that student class. So this is similar to when we used integer.parseInt. We're using integer, which is the name of the class. And so static, you can just use the class to reference its methods. Otherwise, all the other ones are not static, so you had to use a particular object, and that's because each name and age will be unique to that object. Hopefully that makes sense, and I think writing your own will really make a big difference. Good luck.